Okay, when we finished lecture 4, we were talking about a project with 2 IRRs. So this is lecture 5, chapter 9, CFIN7. So our solution for this is what's called modified internal rate of return. So what we do is we calculate the IRR, but we use a reinvestment rate assumption. So one note is if you use Excel, they have it actually has 2 rates. A discount rate assumption and a reinvestment rate assumption. Some companies use multiple rates. So with modified internal rate of return, we're going to assume a reinvestment rate. So we're going to, instead of present valuing everything at the internal rate of return, we're going to present value it at the modified internal rate of return. So we take the present value of those cash flows and the at 1.1, and then we discount them back at the modified internal rate of return to calculate the modified internal rate of return. So what the I misstated. So the modified internal rate of return discounts all the negatives and then future values all the positives. So and then we calculate the IRR after that. This gives us one solution. So in this case, we would have using a financial calculator for project S, we should get a modified internal rate of return of 11.45%. So the one thing about the BA2 plus, the modified internal rate of return function can be a little bit squirrely. So we still have it entered in our calculator. So if we go back IRR and compute, we came up with 13.11%. If we go down arrow, we have RI. RI is reinvestment rate. So in this case, our reinvestment rate assumption is 10%. And then we go down to, and it calculates itself. So it did actually calculate correctly. Mod is the MIRR, modified internal rate of return of 11.45%. So it did calculate correctly. So we could do the same for Project L, and we should come up with 10.98% for the modified internal rate of return. So moving on, a traditional payback period. So traditional payback period is the old-fashioned way of evaluating projects. So it's just the length of time it takes to recover the original cost of an investment. There's no present valuing of cash flows. So we're actually comparing cash flows from different years, which is flawed by nature. So the payback period is simply the number of years until it's recovered. Then we add the portion. We calculate the partial year. So we're taking the amount that we need to recover in the final year, and we divide it by the total cash flow. So that gives us the fractional year. So we'll see it on the next table. So we look at project tests. So the decision rule is project is acceptable if payback period is less than N, where N star is the number of years determined by the firm. So we take project S. So we had an initial cash flow outflow of $33,000. We recover $1,500 of that in the first year, so we have $1,500 more to recover. So and then we recover $1,200 in the second year. So that leaves $300. So we have it's 2 years until the final year, which we take this $300 and we divide it by the $800. So it's because we have $300 to recoup, so $200 plus $300 divided by $800 is 2.4 years. Now the payback period for L would be 3.3 years. Because of the flaws associated with the traditional payback period, we have discounted payback period, and your calculator actually does that calculation here. We'll go here. So if we go to NPV, and then let's go 10, enter, and compute. So this was our original calculation. If we go down arrow, first is net future value, which we're not using here. Payback period, we compute 2.38 years, or 2.4 years is what the book calculated. So, and then down below, is one cell hit down arrow one time, we have discounted payback period, and that's 3.21 years. So the calculation is the same, except for we discount the cash flows at the required rate of return. So we discount we're taking the present value of all the cash flows. So what we use to calculate this NPV. So we had a $3,000 initial cost, and then we recovered $1,363 in the first year. That leaves $1,636. So then our discounted cash flow is $971 in the second year, so that leaves $644. And then we have recovered $601 of that in the third year. That leaves $43.57. So the 3 years plus the $43.57 divided by the present value of the 300, which is $204.90. That it gives you 3.21 years, which we calculated on the calculator. The one thing to note, Excel does not have a payback period function. I was kind of surprised at that, but I did Google it, and apparently it does not. But if you use Excel, you would need to do the present value cash flows and do the calculation as it is shown here. All right. So the next slide is the last slide for the chapter. So, capital budgeting methods used in practice. We were able to use more sophisticated methods than we used previously because 40 years ago we didn't have and 40 years ago we did have financial calculators, but prior to that we did not. So financial calculators are an invention of the 1970s. So and financial calculators came along in the late 70s. Spreadsheets came along in the 80s. This made life much easier. So so we've evolved. So most companies use multiple techniques when making an investment decision. So we also do perform sensitivity analysis. So we want to look at those NPV profiles based on different assumptions. So that is a conclusion for Chapter 9 of CFIN7.